Welcome back, friends. In today's video, we will see how to find orthogonal surfaces. Okay, now to find orthogonal surfaces, we have two types. First is, let us say we are given a function f of x comma y comma z equals to some c1. Okay, in such cases, we can find normal to that particular surface, which is an orthogonal surface in the form of p into dou f by dou x, that is differentiating the given function with respect to x plus q into dou f by dou y minus dou f by dou z equals to 0. Once we get this partial differential equation, we will solve it. And the result that we will get will be orthogonal to the given surface. That is, it will be a normal. The second type is we will be given instead of function a partial differential equation like this, which we had been solving earlier. Once we are given this, what we will do is that we will take this p, q, and r and write a normal equation as p dx plus q dy plus r dz equals to 0. And once we get this, we will solve it. Okay. And once we get the result, it will be our normal equation. Let us see these things through an example. Let us say we are given a function f as z into x plus y whole divided by 3z plus 1 equals to c. Now, if you observe here we are not given a partial differential equation but a function. So it is of type 1 and we are asked to find orthogonal surface to it. Okay. So first let us find dou f by dou x, that is differentiating the given function partially with respect to x. We get z by 3z plus 1. Similarly, dou f by dou y and dou f by dou z. Once we have these three values, okay. Once we have these three values, we will put in our equation, which was p into dou f by dou x plus q into dou f by dou z. Sorry, dou y plus, sorry, it was minus dou f by dou z equal to 0. Okay. So here once you put these values, this is what we will get. Once you simplify it, see this 3z plus 1, 3z plus 1, 3z plus 1 whole square. So if we multiply by 3z plus 1 whole square throughout, here this will get cancelled out, this will get cancelled out, this will get cancelled out. And this is the equation that we will get. Okay. Now, if you observe this, isn't it in the form of pp plus qq equals to r? To solve this, what we used to do? We used to write Lagrange's auxiliary equation and we used to solve it, right? That is the same way we will solve this as well. So here we are writing Lagrange's auxiliary equations, right? Dx upon this particular term, dy by this particular term, and dz by this term. Now, if we take first two ratios, this 3z plus 1, 3z plus 1 will get cancelled out, and we will be left with, even this z will get cancelled out. We will be left with dx equal to dy. Okay, this is what we have written here. And once we integrate it, we will directly get x minus y equals to some constant c1. Similarly, let us say now if we see, it is difficult to separate these things. Okay, so from this particular equation, x minus y equal to c1, let us take x equal to y plus c1. Okay, and substitute it here. So what shall we get? See, dy upon z into 3z plus 1 equals to dz upon x plus y. And we have substituted this particular x with y plus c1 here. Okay. So the final equations that we are getting is that dz, dy upon z into 3z plus 1 equals to dz upon 2y plus c1. So basically what we are trying to do is that, see, here we know all the terms are in the form of z, but here we had a x term. We try to eliminate that x term so that here we have all the terms in terms of y, and once we take these two ratios, we can integrate them without worrying about the unknown which was x. Okay, so cross multiplying it, this is multiplied here, and this particular term is multiplied here. That is what we have written here. Now it is easily integrable, like y square plus c1y equals to, it will be 3z square. Integrating it, it will give z cube by 3 into 3. 3 will get cancelled out, so it is z cube. Okay, similarly z square by 2 plus c2. Now observe here, this c1 we will have to replace back, which was x minus y. Okay, I guess I have done it here. Hmm. So we have replaced c1 here. c2 will remain as it is because c2 was an arbitrary constant for a second equation. And just simplifying it, you will get this as answer. Okay, 2xy minus 2z cube minus z square equals to c2. And finally, we will write answer in the form of phi of c1 comma c2 equals to 0. Okay, this is the required orthogonal surface. That's it. In the second video, we will see how to solve type 2 problems. Okay, thank you.